Question 1. We've got to work out 2 3/5 minus 1 5/6. Well, the first thing to look at is to make these a little easier for yourself. So the first thing I'm going to do is I'm going to make this one into fifths. So I have 3/5 and 2 whole ones. Now in each whole one there is 5/5, so there's going to be 10/5 and 3/5 here, which is going to give me 13/5. And then I've got to take away 1 whole one and 5/6. Well, the whole one is 6/6 and 5 more, which is 11/6. Now we want to do 13/5 take away 11/6. So we're going to make the denominators match. So if we times top and bottom here by 6, and I'm going to times the top and bottom of this one by 5. So in effect, what I've done is I've times this by 1. So 1 times 13/5 is still 13/5. And then I've got 5/5, which is 1 times 11/6, which is still 11/6. So that's the idea of getting the denominators the same. We're timesing top and bottom by the same number, which is like timesing the whole fraction by 1, which does not change its value. So we're left with 78/30, take away 55/30, which will give us 23/30. Question 2. Phone calls cost y pounds for x minutes, and the graph gives the values of y for the values of x from 0 to 5. For the first part, we have to give an interpretation of the intercept of the graph on the y-axis. Well, what would you say? Well, I would say things like, it tells you there's a fixed charge, because even though you haven't made a call yet, there's still a fixed payment to be made. And I think if you want to zoom in on here, you can see that it would be 50p. Let's get my handwriting a bit better here. So 50 pence. So I've said this is a fixed charge, an amount paid for a phone call before time has passed. Now we've got to give an interpretation of the gradient of the graph. Well, I always look at it as moving along 1 unit on the x, and then to see how far we go upon the y-axis. Now, for here, we can go 1 unit along, and we can go up here by, and it looks like £1.50, but if you want to make it clearer for yourself, then by all means go along 2 units. And the nice thing about 2 units is you go up by a nice amount that you can see exactly. And you can see here it's gone up by 1, 2, 3. So if you scale down the larger triangle here in red to the one in green, you divide everything by 2, because 2 divided by 2 would give you 1 here. So if you divided the 3 by 2, you'd get 1.5. Okay, so what can we say about the interpretation of the gradient of the graph? Well, we can say that is how much you pay per minute for a call. Now, we have the gradient, so the gradient was for every one along, we went up 3/2. You could say 1.5, but 3/2 is fine. And we know what the intercept was, and we worked that out here. Now that was 50p, so if we want to get the units to match the 3/2, then we'd have no problem with saying a half there. So y would be 3/2x plus a half. Question 3. ABCDE is a pentagon, and we've got to work out the area of that pentagon. So I'm going to split it up into, as I'm sure most of you would, a nice triangle there and then a rectangle. So I'm going to do the rectangle first. So the rectangle, well, the area of that is just going to be 4 by 8 centimetres, which gives 32 centimetre squares. And then I want to find the area of this triangle here. So what I'm going to do is I'm going to split it up into two smaller ones. So this will be 4 here. I'm going to use Pythagoras to work out the height. Now you should be able to see this is a Pythagorean triple, i.e. 3, 4, 5. If you can't see that, then square the lengths. You get 25 here, square this one, you'd get 16. To find the smaller one, don't forget you'd have to do 25, take away 16, which is 9, and then square root would give you 3. So we know that we can do this in two different ways now. We could either find the area of the whole triangle, which is base, which should be 8 this time, times the height, which is 3, and then halve that instead, and that would find us the whole area of the top part. And so we can do a bit of cancellation, and that would give us 4 times 3, which is 12 centimetre squares. So the total area that we would require would be 44 centimetre squares. So with this question, we've got two travellers here. We've got Tarek and Jill. Now we want to write down some information here because it's all about average speed here. Now if you want to know the details, then you need to firstly look at the time that it took. So for Tarek, the time was 2.5 hours. What else can we work out? Well, the average speed was 110 miles per hour. So we should be able to work out the missing link here. So if you think of speed and if you think of miles per hour, it's like miles, which is distance, divided by hours, which is time. So you can say speed is distance over time. Then we can also see if speed is distance over time, if we times both sides of this equation by t, we would have st equals d. So we can find out the distance by doing the speed times the time. So you can use your calculator. So if we look at the first one here, for Tarek, we can do 110 times 2.5, and that is 275 miles. Well, now what we can do is have a look at Jill's information. Now, I'll just write some of this straight down. So, what can we see first? Well, Jill travelled from Manchester to London again. Jill's train also left at 8:35 but was diverted. The train had to travel an extra 37 miles. So if we do 275 and 37, that will give us 312 miles. So that's important to know. And it says work out the difference between the average speed of Tarek's train and the average speed of Jill's train. Well, everything's in the question, so we can see here that the total time that it took was 3 hours for the journey. So we can work out the missing link here, which is the speed. Now if we use the one we had before, speed is distance over time, then we can have the distance here as 312 divided by 3, and on your calculator or in your head you can see that's 104 miles per hour. So now we can work out the actual difference between the average speed for Tarek and for Jill, and we can see here that the speed for Tarek on average was 110 miles per hour, and for Jill we've just worked out it was 104 miles per hour, so we can see 6 miles per hour is the difference. Now that's reasonably tricky, but just try and think. The only thing you need to know for this question, and I'll put this in a separate colour here, if you just know that when you've got a number like 110 miles per hour, then you know that that is a speed and it's given as a distance per unit of time, i.e. distance divided by time. And if you know that and you know how to rearrange it, then it's just a matter of finding the missing one in each case, and it will always give you enough information to work out the missing one, be that speed, distance or time. Question 5. The diagram shows a rectangular wall and it measures 6 metres by 1.8 metres. Now the first thing I'm going to do is just draw a little diagram of that, and I'm going to convert everything to centimetres first, which I think will make it easier. Now if you look at the tiles, they measure 60 by 30 centimetres, so you could definitely get 10 across the bottom here, and well, I'm sure you've worked this out, you can get 6 going up. So it's 10 by 6, so that'll be 60 tiles. Okay, so that's the first thing to work out. Now, we know that 3/5 of those 60 will be white, and we can do that on our calculator, or however you want to do it. I'll do it by hand here. And 3/12, that gives 36. So we've definitely got 36 white, so let's put that in. Now, some of the tiles will be green and the rest will be blue, and it says the ratio of the number of green tiles to the number of blue tiles will be 1 to 3. So let's just get that right. So if we've got green to blue in the ratio of 1 to 3, then because we knew there were 60 tiles to begin with and 36 of them have been used up, that would leave 24 tiles to be either green or blue. But in the ratio 1 to 3, can you see that's the same as 2 to 6 or 6 to 18? Because to get from 1 to 3 to 2 to 6, I can just double both sides. And then to get to 6 to 18, I can then times both sides by 3. Or I could have just started from 1 to 3 and times both sides by 6 to get 6 to 18. Now that's important because 6 and 18 make 24. So the nice thing about that is, if we just follow the key here, G was the left hand side of the ratio, so that would be 6 green, and then what's left would be 18 blue. Now the next part here seems a little strange, seems a bit obvious, because if you're asked to leave gaps between the tiles, then how would this affect it? Well, very simple. I would just write less tiles are required. Okay, and that's that question done. Question 6. On Monday, Ria delivered a parcel to a hospital, and the travel graph represents Ria's journey to the hospital. So the first thing we need to look at is that Ria left home at 1300, and she drove for 30 minutes at a constant speed of 40 miles per hour. So this must be 1330 here, because that represents the 30 minutes here, and a constant speed of 40 miles per hour, so that's 40 miles in 1 hour. Well, if you think about it, if we halve top and bottom, we'd get 20 miles in the half an hour required. So we know from here this must be 20 miles here, so we can look at this scale: 5, 10, 15, 20, 25, 30, 35, 40 and so on. Okay, so that was quite important. 20 miles in half an hour is 40 miles per hour. So that's the first thing we've got sorted. She then stopped for a break, and Ria then drove to the hospital at a constant speed. So this would be this part here. So that's another half an hour. So we've now got 1400 hours here. Now, she was at the hospital for 30 minutes. Now, that's the important thing to look at. So Ria then drove to the hospital at a constant speed, and she was at the hospital for 30 minutes. So this part shows her journey to the hospital, and then we've got to put in another 30 minutes here. So let's look at our scale so far. So 13, 13:30, 14, 14:30, and then 15, 15:30, and then 16, and then 16:30. So it says she then drove home at a constant speed of 32 miles per hour, show that she does not arrive home before 16:30. Well, I think what I would do here is I would assume that I've got home at 16:30 and then work out what speed that would have to be and see if it tallies with what we're given. So give me a moment to get a straight line up here. I'll do that in red, I hope. And then it is a little bit larger than what I wanted, but it will do for now. And what we can see from that is, if we look carefully, is this gap here, which coincides with this gap here, would be our time, and we can see that is 1 hour. So if we look at this scale here, we know that this represents 40 because it was 40 here, so it's 40 there, all the way back. So that's 40 miles in 1 hour. So evidently, driving home at the constant speed of 32 miles per hour would not be fast enough. So she does not arrive home before 16:30. So that's the explanation I would give. I might write a little bit more after that, but I'm sure you can manage that yourself. Okay, and I've done a little explanation here for you to read. Question 7. We want to work out an estimate for the value of the expression given. So in simple terms, we'll call the 43.2, we'll round that to 40. Instead of saying the square root of 99.05, we'll say the square root of 100. And we'll divide that all by, well, we won't say 0.193, we'll say 0.2. So let's go from there. So we'll use the numerator first, and we'll say that's 40 times 10. And the denominator stays as 0.2. Now, the numerator is not going to be too difficult because we're just going to have 400 there, and the denominator is 0.2. So as this is not a calculator paper, you've got to kind of like think of how are you going to sort this out from now. Well, there's one way, and that is you can times top and bottom by 10. So you'll have 4,000 divided by 2, and that gives you the answer of 2,000, which is the required answer. However, if you couldn't see that, then you start with 400 over 0.2, and then you could say that's 400 divided by a fifth. And depending on how good you are at your fractions, if you write 400 divided by 1/5, that's the same as 400 times 5 whole ones, which again is 2,000. I prefer the first way, but like I said, without a calculator, you've got to think carefully. Question 8. It says a shape A is translated by the vector 4, -7, and that will make us shape B. And then from shape B, that is then translated by the vector -3, -2, and then we end up with shape C. So if you think about it, you want to go from A through to C. So the way of doing that is taking each vector and then adding. But the way we add vectors is important. We have to look at the components. So we have the x components here. So for the first vector we had the x component of 4, and we need to add that to -3, which was the x component of the second vector. Doesn't matter which order we do this in, because we'll still end up at the ending place, which is shape C. So 4 and -3, that gives us 1. And then we do the y components just the same, so we have -7 and -2, and that gives us -9. So the answer I would write here is 1, -9, and that would be how to get from A straight to C in one go, i.e. a single transformation. Question 9, quite a difficult question here. It says a company orders a number of bottles from a factory, and it says the 8 machines in the factory could make all the bottles in 5 days. So let's write that down first. So the 8 machines could make all the bottles in 5 days. And all the machines work at the same rate. So for 2 days, only 4 machines are used. Well, if we halve the number of machines, then to make all the bottles, it would take twice the time, so it would take 10 days. Now we know though from the question that those 4 machines are only used for 2 days. So 2 days compared to 10 days is a fifth. So in 2 days, we'd have 1/5 of the bottles were made. So that's important. So that's 2 days, 1/5 of the bottles are made. Now, from the 3rd day, all 8 machines are used again. Now, if we think back to the original part of the question, it says the 8 machines in the factory could make all of the bottles in 5 days. So the rate at which the 8 machines work at, so 8 machines would produce 1/5 of the bottles a day, because it says it takes 5 days to produce all of them. So from that we should be able to work out the answer, because if it's 1/5 of the bottles in 1 day, and then how many days have we got left? Well, looking carefully here, we've already got 1/5 of the bottles have been made, so we've somehow got to make 4/5 of the bottles and see how long that would take. So if we know that it's 8 machines do 1/5 of the bottles per day, then in 4 days they would make 4/5 of the bottles. Okay, now that's quite important, because we now know that we've got 4/5 of the bottles and 1/5 of them, which makes all of them, and all we've got to do is count the days and we're done. So we've got 2 days here, 4 more, which makes a total of 6 days. I'm sure there are other ways of doing this question. I think this would be my most difficult question on the exam if I was doing it. A, because there's so many words, and B, because things are not perfectly clear straight away. Question 10. Find the value of 64 to the power -2/3. Well, this isn't too bad. If we split it down, if we look at this negative sign here, then that just tells us to find the reciprocal. So that's the same as 1/64 to the 2/3. And then if we split this down here, we'd have 64 to the power of 1/3, then squared. That's a lot easier than doing 64 squared and then doing the cube root of that, or to the power of 1/3. Now, as we don't have a calculator, as I must keep reminding myself, 64 to the power of 1/3, the 3rd root of 64 is just 4, and then we've got the squaring left to do, so we'll end up with 1/16. Question 11. You've got to match the cumulative frequency diagrams with the box and whisker diagrams, and I've copied and pasted this down here. So we're going to see what's the best way of doing this. Well, thinking about it, I would probably look at where the medians are. So in this case, the median would be 160. So it could either be Y or W. So also this one could be 160. So there's an either or situation here. So I'll leave those two out for the moment. This one here, however, gives the game away because this gives us 170. Let me just get my scale right. 140, 150, 160, yep, 170. So C must correspond to Z. Therefore, by elimination, then, and we can check this out here, that 15 would read along to a median which is by lowest of all of them. So that must be X. So B corresponds to X. So we just have to work out A and D. Now, let's look at this one. There'd be quite a large spread here as opposed to this one here where the spread is smaller. So let's have a look at which has the largest spread, and that must be W as a box plot. So we only had this one here and this one here. They were the two front runners. So if you look along here to the lower quartile and then the upper quartile, can you see the gap here is going to be smaller than this one? And this gap is bigger. So the interquartile range of cumulative frequency graph D is the largest, so W must be this one, and then the last one will be Y. So Y, X, Z and W. I hope you understood that. Question 12. In a sale, the price of a jacket is reduced and it started at £52 here. And it was sold at £41.60. So without a calculator, we'll do this subtraction here, however you want to do it. And so it's £10.40 is the difference here, but this is the important part. Work out the percentage reduction in the price of the jacket. So we're comparing the difference there between the normal and the sale to the original price. That's really important. So if we times top and bottom by 10, we'll get 104 over 520. Now if you can't see that 104 goes into 520 5 times, that's fine. If you can, then you'll know that the answer is going to be 1/5, which is 20%. If you can't, although this is a non-calculator paper, you can try it on your calculator and get the experience, but if you still can't see it from there, then you can halve top and bottom and get 52 over 260, halve again, which is 26 over 130, which is 13 over 65, and then 13s into 65 is 5. Hopefully you can see that, and then that will give you 1/5 or 20%. Question 13. Prove algebraically that the difference between any two different odd numbers is an even number. Well, let's look at an odd number. Let's call it 2n plus 1. And let's call another odd number 2m plus 1. That would be the cleverest way of doing it. Now, if we do one take away the other, because you want to find the difference between them, then what happens? Well, we'll end up with 2n minus 2m, because the one take away the other one will vanish. And we'll be left with two lots of n minus m. Now that's really interesting because no matter what n or m are, we'll always have them times by 2, i.e. it will always be in the 2 times table, i.e. an even number. There are other ways of approaching this question, but I think that's the best way. Question 14. It asks you to write 0.6 and then the 2 4 part recurs, so 0.6, 24, 24, 24 and so on, as a fraction in its simplest form. Well, I think what I would do here is I would write it as 0.6 plus 0.024. Then the 0.6 we can cancel down to 3/5 and we can leave that part alone. Now we just need to concentrate on this. Well, if we call that x, then 10x would be, and then we'd see that 100x would be 2.42 recurring, and 1000x would be 24.24 recurring. Now the nice thing about this is if you see 1000x, which is 24.24 recurring, you want to get rid of the 0.24 recurring part, and you can do that in this way. If you do 1000x take away 10x, you'll be left with 990x, and 24.24 recurring with the 0.24 recurring taken away will leave you with 24. So x would be 24 over 990. This in turn would give 3 times 8 over 3 times 330, because I did this with a calculator to start with, and now I realise that you can't use that, so I've got to do it non-calculator way. So that's 8 over 330, which, if I cancel that down, will be 4 over 165. So you just halve top and bottom there. Now, that then has to be added to the 3/5, okay? And this is all without a calculator. I don't like using calculators anyway, but you can't in this paper. So 3/5, I would change that to 165ths, and if you're not sure, then just do 5s into 165, and you'll see that is 33. So if you times top and bottom of 3/5 by 33, and then add it to 4 165ths, the answer will become clear. You'll have 99 165ths plus 4 more of them, which will give you the required answer, which will be 103 165ths. Question 15. Well, there's quite a few ways of looking at this one. I think because we've got a quadratic form of 1/10 x squared minus 3x, then if we look at the form ax squared plus bx plus c, then the line of symmetry would be x is minus b over 2a. Now, for those that don't know that, very quickly, if you're solving a quadratic form of the form ax squared plus bx plus c is 0, you'd have x is minus b over 2a plus or minus the square root of the discriminant b squared minus 4ac all over 2a. So this part here is very significant because it shows you how to get to the halfway mark, and then you add this amount one way and take the same amount the other way and get the solution points. So if we just look at minus b over 2a, then we can see that a in this case is 1/10, b is -3. So we have enough information to find the halfway point, so it would be minus b, so it would be minus minus 3, which is 3 over 2/10, which is 1/5. So we can see from here that 3 divided by 1/5, if you don't know how to do that by hand, then put it in your calculator. But if you times both sides by 5 here, you're going to get 15 over 1, so the answer is just 15. So what this is really saying here is that the line of symmetry here happens when x is 15 at this point. Okay, so x is 15 all the way along here. Now, therefore we can work out the depth here, because if this part here is on the x-axis, then this part is our starting point, and if we put 15 into this equation, back into this equation, we should be able to work out what the y value gives us. It will be negative, and it will be the depth of the bowl that we want. So all we've got to do then is say y is 1/10 of 15 squared, which is 225, minus 3 lots of 15. So that would give us y is 22.5 minus 45, which gives us negative 22.5, and as this is a negative number, we want the length in centimetres, so it's going to be, the depth of the bowl is going to be 22.5 centimetres. We don't need to put the negative sign in there. Question 16. We've got to evaluate, i.e. look at and appreciate what Charlie's method is telling us. And I think from there we've got to either say whether this method is good or whether there's flaws involved. So let's have a look at the first step. It says that going from B to C, so if we want to move from B to C, then that's the same as going from B to A and then A to C. Well, I agree with that. And then, is it true that from B to A is the same as going B, but in a negative sense? Yeah, so that's true there, that's okay. And then plus A, so minus B plus A, yeah, I think that's fine also. And minus B plus A is the same as A minus B, yes, I agree with that. Now, is it then true that BM is a half of BC? So, M would have to be the midpoint in this case. So, first it doesn't say that it's the midpoint, but that's fine, it doesn't have to say that. But let's look at this ratio, and this should give the game away. From B to M is one part, and from M to C represents two parts. So if that represents one part, and this represents two parts, then from B to C would represent three parts of a ratio. So if you think about it, B to M is one part out of three. So it's actually only 1/3 of BC. So I'm afraid that's the mistake. So this should read 1/3 of A minus B. And I should underline these because I can't do them in bold. And that would be my evaluation, and I'll probably write that there. Now, looking at these questions first time round, this one's making me think a little bit. And it says, explain why Martin's solution cannot be correct. Well, it's only 1 mark, so it's got to be something simple. Well, I think that if you multiplied the beginning terms, i.e. the linear terms, so the coefficients of x, you'd have 2 multiplied by 2, which would give 4 multiplied by 3, which would give you 12x cubed, because it would be 2x times 2x times 3x. And then check the last one and see if this is going to be positive 6. Well, 1 times the 2 gives a 2, times the minus 3 would give negative 6. So I would say the constant term should be negative 6, not positive 6. So that's my evaluation of Martin's solution and why it cannot be correct. So you don't need to do all the middle parts, because if that one part is wrong, then this solution cannot be right. Question 17, a circle theorem question. And we're given first of all that angle BDC is 57 degrees. So we can write that in there. And so we can deduce what this angle is, and that will be 33 degrees. And you can write your own explanations here. I'm not going to write every single step down. So why do you think that's the case? Well, hopefully you've seen that A, B and D are points on the circumference of a circle centre 0. So as A and D go through the centre, then AD must be a diameter. And you should know that the angle between a radius and a tangent is 90 degrees. So that would be your explanation to say why that angle is 33 degrees. So you must write that information down. I might write it at the very end when I've worked out what I need to do. So it says find the size of angle AOB. So this angle here, AOB. Now, to do that, we've got to be quite careful. Now, one thing I would write in here definitely is that this is a radius, this is a radius, and this is a radius. Then that kind of opens up some more information, because this angle here must also be 33 degrees then straight away. And can you see why that's the case? Well, because it is a radius and this is a radius, they're the same length, this must be an isosceles triangle, and base angles of an isosceles triangle are equal. Now, as I see these questions first time round, I've just thought of something that I've probably done a bit too much work there, and some of you are probably thinking, well, you've done this question really badly, and yes, I would agree, because I've just noticed that because I've found this angle here, which is 33, that angle here is at the circumference. This angle here is at the centre, and yes, you've got an angle at the centre is twice the angle at the circumference, so I could have just quoted that and had 66 degrees straight away. So I'll write my working out down now, and then you can just have a look at that and see if you agree. So that angle was given, this was 33 because the reason I've stated, and therefore angle AOB is 66, again for the reason that I've stated here. Okay, so I think that should be enough. If you disagree, then do send a comment. But I think this is quite a nice question on sequences. Well, it says, the diagram shows the first 10 sides of a spiral pattern. It also gives the lengths in centimetres of the first 5 sides. It says the lengths in centimetres of the sides are a spiral and they form a sequence, and we've got to find the nth side or the nth term. So it starts as 1.5, which I'm going to call 3/2, and then goes to 3, and then goes to 5.5 or 11/2, and then goes to 9, and then 13.5, which is 27/2. I'll convert these all to halves, so 6 halves, 11 halves, 18 halves, and 27 halves, of course. And then we can see that the difference is going up by here, 3 halves, then 5 halves, then 7 halves, and then we've got 9 halves. So it's not going to be a linear sequence, it's going to be a quadratic one. So I would be thinking to myself, well, what do the square numbers give? Well, the first square number would be 1, the second square number would be 4, and then the third one would be 9, and then the fourth one 16, and so on. And then what I have seen is, and that's that if we do half of n squared, we'll get a half, and then 2, and then 9 halves, and then 8. Now, the interesting thing to notice about this is that if we compare this with where we started, here we had a half, and then here we had 3 halves. Well, it then seems that n squared over 2 is good if we just add 2 more halves to it, or 1. So let's just see if this works for the next one. N squared over 2 for the second value of n, i.e. when n is 2, would give us 2, or 4 halves. But if I can compare that to 6 halves, well, it seems good. So n squared over 2 is good, as long as I add 2 more halves to it, because 4 halves here and 2 more halves make 6 halves. So it seems as though if I add n squared over 2 to 1, I would get my answer. Let's check the next one. 9 halves here and 11 halves here. Yes, 9 halves is good, so n squared over 2 is fine, and if I add 1 more, or 2 halves, I'll get the answer. So that's the way I would personally approach this, and that is n squared over 2 plus 1 more. If you wanted to use decimals, then that's absolutely fine. I think another way of doing it is that if you knew the quadratic form an squared plus bn plus c for some values a, b and c, then you know, for example, that a plus b plus c, well, that's only when n is 1, would give us 3 over 2. You also know that when n is 2, that would give us 4a plus 2b plus c, and that would give us 6 over 2, or 3. And then finally, you probably worked out here that 9a, i.e. when n is 3, 9a, putting it into here, this quadratic form, 9a plus 3b plus c, well, that would be 5.5 or 11 over 2. What you could then do is you could solve simultaneously these equations, and it's not as hard as you think, because you've basically got one of them here and another one here and another one here. So if you eliminate c from, say, this one and this one by taking them away from each other, and then do the same to this pair, so don't use the same one twice. So for example, well, I shouldn't say don't use the same one twice, what I mean is use this one and then this one and this one, and eliminate c each time, and that will give you two equations in a and b. I'm just trying to think what that would actually give you. I think if you tried it, you might end up with something like 3a plus b is 3 over 2, and 5a plus b is 5 over 2. And then, of course, you could eliminate b by taking them away, and you would end up with 5a minus 3a is 2a, b take away b is nothing, and 5 halves take away 3 halves is 2 halves, which is 1, so that would give you a as a half. And that's really important because that's a half n squared, which is exactly what you had here. Okay, and then once you've got a, you can then find b by substitution and then find c, and you'd find that c would be 1 and b would turn out to be 0, okay, because there was no n term in here. But I think this way is probably better. The simultaneous equations way, probably a little bit slower and a bit more work. Question 19. Well, the way I'm going to do this question is I'm going to draw two separate triangles out here, and I'm going to call this one A, B, D, and I'm going to draw another one here, and I'm going to call that C, B, A. Now, this is a right angle here, and you can see that from the diagram, and this is a right angle here. So we could say that angle DAB is equal to angle ACB. Okay, so that's the first thing. Now, if we look carefully at angle ABD in the large diagram, it's the same as angle ABC. So that's useful because I can then call this x here and then this x as well. Okay. Now, that's the first thing to look at. Now, we're trying to show that triangle ABD is similar to triangle CBA, so we're not trying to show that they're exactly the same or congruent. We're just showing that one's an enlargement of the other. Now, what we could do is look at the fact that it says that AB here, we'll call that, say, y, then that's going to be y here. So I think we've got a situation where we've got three angles are the same, because if we think about this, this angle is found by saying angles in a triangle are 180 minus the right angle here minus the x. But this angle here is also found by doing 180, which is the sum of all the angles, minus the right angle here minus the x. So all three angles are the same, so I can say three angles the same. So that could mean they're congruent, you see, but the nice thing is that this y here corresponds to the y here, but this y is opposite the right angle, whereas this y is not. It's opposite an acute angle. So they're not congruent, therefore they have to be similar. So you can write that last little part down. I know what I'm trying to explain, but I hope you can see it. You don't want to show that they could be congruent, you want to rule that out. And that's the significance of saying the y there is opposite this acute angle, whereas here it's opposite the right angle. And you should know that if it's opposite the right angle in this one, y would be the greater length. But in this one, it's one of the shorter sides, it's not the greater one because it's not the hypotenuse. So that should be enough for that question. But I think that's the toughest one for me on this paper anyway, but some of you have probably found it very easy. Question 20. We've got to solve algebraically x squared plus y squared is 18 and x minus 2y equals minus 3. Well, what I would do is I'd go from the straight line form, x minus 2y is minus 3, and rearrange that in terms of x, and then substitute into here. Alternatively, you could rearrange this part in terms of y and have x plus 3 over 2 equals y, and then substitute that in, but that would be a bit more complicated. So we'll have our circular form and our linear form. This is a circle. It's in the form of x squared plus y squared is r squared, where r is the radius, and this is a straight line form. If you're not sure on the circle form, then you can do some research. So I'm going to substitute this into here. So 2y minus 3 all squared plus y squared is 18, and that's the quadratic form in y. Be careful when you multiply out the 2y minus 3 that you don't forget these terms here, which sum to negative 12y. So you'd have 4y squared minus 12y plus 9, anything squared is always positive, plus y squared is 18, so you'd have 5y squared minus 12y minus 9 equals 0. Now by the time you've done this much work, there's probably very small chance it's going to be completing the square or anything fancy from there. It's probably just going to be straight factorisation, and in this case it does nicely. 5y plus 3 times y minus 3. So that would give us 5y squared minus 15y plus 3y, which gives us the minus 12y. And then we've got the minus 9 there. So we have y is minus 3/5, or y is 3. Now, in this case, it meant that we had a circle and we had some form of a straight line, and it had a positive gradient, and say it had two cutting points. So we're going to have two pairs of coordinates. One when y is 3, and if we want to know what x is, then we're lucky because we've got this form here. I'll just highlight that here in red. So if y is 3, we'd have 2 3s are 6 minus 3, x would be 3. And then that would correspond to one of the coordinates here where the circle meets the straight line. But you don't have to know that in terms of the graph. It's just helpful to sometimes know that a graph always lies behind the algebra. Now, we can always have a look at y equals minus 3/5 in the same way, because we have x is twice what y is from here. Minus 3, so we're going to have minus 6/5 minus 15/5, which is minus 21/5. So I would give my answers as intercept 1 would be 3, 3, and intercept 2 would be minus 21/5 minus 3/5. So that'd be my answers. Question 21. We have 3 plus root 2 divided by 5 plus root 8. And we've got to write this as given, and we can notice here that the denominator is a whole number. So the best thing to do is to rationalize the denominator. Now, the best way of doing that is to times by the same number, and in this case 5 minus root 8. And the reason we can do that is because 5 minus root 8 divided by 5 minus root 8 is 1. And if, like I said before, if we times a fraction by 1, we get the same value. So on the numerator, we're going to have 15 minus 3 root 8 plus 5 root 2 minus root 16. And then the reason for timesing by the conjugate, or the opposite sign here, is because we have the form a plus b times a minus b, which always gives the difference of two squares, and the difference of two square numbers is always a whole number. So in this case, that would give us 25 minus 8, which is the 17 as required. So all we've got to do is neaten up the top part. Well, this is 4, and this is 15, so that's going to give 11. And then we've got 5 root 2 minus the 3 root 8. Well, this gives us 11. And then we've got to try and get minus root 2 out of this here. Well, 8 is a number which has a square number as a factor, i.e. 4. So the 5 root 2 is in its lowest form, so we're hoping that this root 8 can be written as root 4 times root 2, which it can. And then we've got 5 root 2 minus, well, 3 times root 4, well, the square root of 4 is 2, so that would be 2 3s are 6 root 2. And then luckily we have 11, and then we've got 5 root 2 minus 6 root 2 is minus root 2 over 17, which is where we wanted to end up. Question 22. Now, this is an interesting question. It says graph A is a reflection of the graph of y equals f of x. So this is our starting point, y equals f of x, and we have to see what's happening here. Well, there's definitely a mirror line going on here in the y-axis, so that should give us some clue, because if we pick a point here, say x is minus, we don't know if that's minus 1, but it's definitely minus something, that corresponds to the same scale here, and it then becomes positive. I've just called it 1 just for argument's sake. So it seems like the x values here become the negatives of the x values we had here, i.e. negative 1 becomes positive 1. So that's of interest. Now I can see this point here corresponds to the negative of this point here, and so on. So I think that's quite easy to say that graph A must correspond to the x values of f of x, but the negative of those values. So I would put f of minus x. That would be my answer. Now, the next part looks a little bit trickier than it is, but I think you can see an upward translation here. Okay, no matter where you are along here. Now, if we know we have g of x from our basis, then to get to graph B, we seem to be going up by, well, we can work out the unit now because this is 2, so this must correspond here to a gap of 1. So it's just an upward translation, so parallel to the y-axis. So I would write g of x plus 1 in this case. So for the last part of this question, we've got the graph of y is cosine of x. Now that's quite important to start with, because you should know that cosine of x is trapped between 1 and negative 1 here. So we definitely know that the y-coordinate of c is at the lowest point, so that's definitely going to be minus 1. But we've got to think what value will give us a cosine which is have a length of -1. Well, if we look at the unit circle, and if you're not sure about the unit circle, you can look it up on my YouTube videos or somebody else's, just type in unit circle. If you have an angle of 0 degrees, the cosine would be just here, it would be worth 1. If you had an angle of 90 degrees, then there'd only be a sine here, there'd be no cosine at all, so the value would be 0. But if you went to 180 degrees, then you'd have a cosine, I'll put it in red, of, well, it seems like 1, but it's in the negative sense, so it would be a value of -1, as opposed to here being +1. So if you get your head around the unit circle, then you would pretty much realise here that this would have to be 180 degrees here. Now, we don't have a calculator here, because I think that would be too easy to just guess some values there and put them in. So you really would either have to know the unit circle or pretty much know the cosine curve very well. So if we put this in here, we know this is 0, so what angle would this have been? Well, that would have been 90 degrees there at that particular point. This is 180, so if you think about it, if we do another colour here, say yellow, then if we go round 270 degrees, then all we've got left here is sine, so again the cosine would be 0 at this point, and indeed it is, so that would correspond to 270 degrees there on the x-axis. Okay, so that's the last question of the paper. Question 24. Quite a difficult probability question, and I think the best way of doing this is to label very clearly what your intentions are. So we want to go from bag A to B, and then we want to go from bag B to C, and then we want to see the result in bag C. So let's look at the tree properly. So in the first situation here we have 6 in 10 and 4 in 10 for black and white respectively. And then the situation in bag B would be now 11 in the bag, but 8 of them being black and 3 being white, because don't forget there was already 7 black and 3 white in there. So we can label that carefully. And then 7 out of 11 and 4 out of 11, depending whether we put a white in or not. So what results do we have in bag C? Because don't forget, he then takes at random a counter from bag B and then puts that in bag C. And it already tells you there's 5 black and 5 white in there to start with. So they could either be, and I'll write that different colour, 6 black and 5 white, or 5 black and 6 white, because a white could have gone into bag C. Or we could have had the situation where we have 6 black and 5 white, or 5 black and 6 white. Okay, so they're the 4 different outcomes we can have. Okay, so think about it as the 4 outcomes of the tree diagram. And we want to find the probability that there are now more black than white. So we're going to have this situation here and this situation here. So how did we get to here? Well, let's have a look. We went 6 in 10 and 8 in 11. So 6 in 10 multiplied by 8 in 11 would give us 48 out of 110. And how do we end up here? Well, 4 in 10 by 7 and 11. So 4 in 10 by 7 and 11 gives us 28 in 110. And then we basically add these together because these are our final outcomes. So we'd end up with 48 out of 110 plus 28 out of 110, which gives us 76 out of 110. I personally would give that as my final outcome, as my answer, because 110 shows us the different possibilities, but you could cancel that down and give it as 38 out of 55, which is fine also.